Hi, I'm Carolyn Bertozzi, and I'm the Baker Family Director of Stanford ChEM-H. We are an institute that combines chemistry, engineering, and medicine in the service of human health. We focus on molecules and making molecules work to improve human health. And we do this by bringing together the chemists, the biologists, the engineers, and the doctors who can help us understand what are the big problems that they're facing in patient care today. Well, in 1989, when the Berlin Wall fell, I was a graduate student at UC Berkeley. And I remember in my laboratory, we had several German postdoctoral fellows who were talking a lot about what a big moment it was and how it would forever change the geopolitical nature of the world, but in particular, the incredible impact it would have on science, which is now more globalized than ever. When I was a kid, my dream was to become a rock star. And I learned how to play the piano, which took me one step closer to that dream. And I even went so far as to play in a rock band when I was in college with some outstanding musicians who actually did manage to become rock stars. But instead, I ended up pursuing chemistry. I moved to Stanford University back in 2015 to help build a new institute that would break down the walls, not only between disciplines like chemistry and biology, but also to integrate engineering with the basic sciences and to destroy the wall between science and medicine. This beautiful building behind me is where Stanford ChEM-H is centered. And in that building, we have laboratories for making molecules, laboratories for growing cells, laboratories for making instruments, and for generating new computer algorithms. It's a truly multidisciplinary building with no walls between the science. ChEM-H is a place for people that are multidisciplinary. They speak the languages of many different fields. And people like me, we don't fit in all that neatly into a conventional academic department, because I'm not just a chemist or just a biologist. I need to combine these things together. And that's what ChEM-H is all about. It's about bringing the biology and the engineering and the molecules together with the influence of the doctors telling us what are the most important unmet needs in medicine. The ChEM-H building is a pretty special building. We're creating a workspace that's quite different from more traditional research facilities. And can you tell us about what your research will be like in the building and how the building might contribute?
Yes, absolutely. So the building has these neighborhoods that has 2 to 3 labs sharing a lab space, and I'm excited to be surrounded by people who are, engineers and people who study viruses, and I think that kind of environment is going to be quite helpful, not only for me, but for my trainees, so they have an opportunity to learn and have their work be inspired by those other disciplines.
At the end of the day, the problems in human health are so vast and so difficult that we really can only make progress with teams.
Absolutely.
Now that's why I came to ChEM-H, because ChEM-H is a place that I can not just do basic research and understand the molecular mechanisms of disease. It's also a place where I could try to translate what we learn in our laboratory into real solutions for patients. And this is why it's so critical that we have the hospital, the sciences and the engineering, the doctors and the researchers working side by side in the same building where ChEM-H is located. Before I moved to Stanford, I spent 20 years in a top-notch university with really strong chemistry and really strong biology. But the piece that I was missing was medicine, and also
the collaborative, interactive spirit that a place like Stanford brings, where everyone is so close together on one campus. So since I moved here, my research program has changed in a number of very exciting ways. First of all, we're much closer to medical science than we used to be. And we collaborate with a number of physicians who've helped us craft the right kinds of medicines that are needed, especially in the field of cancer immune therapy. I have found Stanford to be incredibly collaborative in every way. And in fact, looking at the research publications that we've put forth over the last 5 years, I think I counted the other day, I have something like 20 new collaborations among Stanford faculty. Now, an interesting question is, how do we start so many collaborations in such a short period of time? And I'll tell you, the answer is it was easy, because the students made it happen. And that's another wonderful feature of ChEM-H. We have top-notch graduate students coming from lots of different backgrounds, all getting trained together with the same mission of taking molecules and making them work for human health.
One of the major challenges in biomedical research is having a workforce that represents the diversity of the patients that we seek to help. And of course, ChEM-H, the letter H, stands for human, which means that it is our mission to improve the health of all humans. And to reach all humans and understand what problems we can contribute to requires that ChEM-H has a diversity of faculty, a diversity of doctors, a diversity of students and postdoctoral fellows, and diversity across all the axes that matter: gender diversity, racial diversity, ethnicities. We need to have a workforce that reflects a socially just world in order to have the impact that we want to have on human health. So if I'm up at night worrying about an element of our institute, it's how to ensure that we have a diverse workforce that can then contribute in the best way possible to improving human health for patients.